Hey everyone, I am Joey Salmaguinay from BSED Sciences. In this video, we were going to talk about which graph is best and what are the variations in the shape of frequency distribution. But to further understand, let's first have a short review about what is graph, its importance, and what are the types of graph. And then let's explore what are the variations in the shape of the frequency distribution. So, graph is a pictorial representation of data in an organized manner. A diagram showing the relation between variables and quantities, typically of two variables, usually series of points, line segments, curves, or areas. So what are the importance of graph and why we use graph in quantifying information or data? The purpose of a graph is to present data that are too numerous and or complicated to be described in the text or in a less space. It is to condense large amount of information into easy to understand format that clearly and effectively communicate important points. But what are the types of graph? Actually, there are so many kinds of graph in using data analysis, but let's choose the most common. First is the bar graph. This graph represents by a spaced rectangular bars that describe the data points in a set of data. It's sometimes horizontal or vertical. We have also pie chart is a circular graph used to illustrate numerical portion in a data set. This graph usually divided into various sectors where each sectors represent the proportion of a particular numerical element in the set. This pie chart has the total sum of all segment needs to be equal to 100%. This line graph is represented by a group of data points joined together by a straight line. Each of these data points describe the relationship axis on the graph. It may be ascend, descend, or do both. Depends on what kind of data is being visualized. This is used to compare changes over the same period of time. Fourth is the scatter plot. Is used when a variety of observation or measures have been taken that are not necessarily collected consecutively. This is to highlight relationship. For example, a scatter plot may be used to represent the scores obtained by a class on standardized achievement tests. In this type of graph, each point is independent. This graph commonly used for assessment tool for identifying temporal pattern in the occurrence of behavior problems. And then histogram. This is used to summarize discrete and continuous data that are measured on an interval scale. The y-axis represents the number count or percentage of occurrence in the data for each column and can be used to visualize data distribution. And now let's move on to frequency distribution. As we all know, frequency distribution is a list table or graph that display frequency of various outcomes in a sample. It is a representation either in a graphical or tabular format that displays the number of observation within a given interval. So, in determining the variations and the shape of the frequency distribution, we have a basis. First is the number of peaks, skewness of asymmetry, and the cortices or the pointedness. Number of peaks. The shape of frequency distribution of a small sample is affected by a change variation and may not be a fair reflection of underlying population frequency distribution. Check this by comparing said samples from the same population or by increasing the sample and should become less obvious as size increases. So genuinely, in determining the number of peaks, you can identify this either it is bimodal, polymodal, or unimodal. So when we say unimodal, it describes a graph that has only one peak, and the bimodal has two peaks, and also the polymodal has two or more peaks in one graph. Next is the skewness of asymmetry. So as we all know, in frequency distribution, we have a normal distribution or the symmetrical distribution that are bell-shaped distribution. And the next is the asymmetrical distribution. And let's further discuss what are the skewness of asymmetrical distribution. So in asymmetrical distribution, we have a negative skewed distribution and positively skewed distribution. A distribution is skewed if it is not symmetrical or asymptotes being that mean, median, and mode are not equal. So positive skewness is where the longer tail of the distribution occurs for higher values of measured variable. When we say negative skewness, in where longer tail occurred for lower values. If the scores are pulled towards the right due to the presence of more high extreme scores, then it is negative skewed distribution. And when we say if the score are pulled towards the left because of the presence of more low extreme score, this is positive. Skewed distributions frequently occurs in the study of chemical measurements or gradings owing to the presence of occasional gross errors. Lastly is the kurtosis. It is the name given to the which means pointedness of a frequency distribution. So in kurtosis, we have platykortic and leptokortic. When we say platykortic, it is one with flattened peak, while the leptokortic distribution is one with pointed peak. The term platykortic refers to a statistical distribution in which the existing kurtosis value is negative. For this reason, a platykortic distribution will have thinner tails than a normal distribution will, resulting in fewer extreme positive or negative events, while the leptokortic distribution or distribution with positive kurtosis larger than that of a normal distribution. A leptokortic distribution means that the investor can experience broader fluctuation, resulting in a greater potential for extremely low or high returns. I think that would be all for my topic, and always remember that the shape of the frequency distribution may vary in the number of peaks, skewness, or the kurtosis or the pointedness of the shape of frequency distribution.